In this video, we were going to be looking at graphs, and we're going to be determining where in the domain, remember those are your x values, where the y values are increasing, decreasing, or perhaps constant. We're also going to be looking at what's called relative maxima. Those are high points, and relative minima, and those are low points on your graph. So maxima is a point where a function changes from increasing to decreasing. So we're going up and then down, and that's a maxima. And a minima, and again that a makes this word plural. Thank you, Latin. And so a relative minima is where the function goes from decreasing to increasing, and we get some minimums. So let's look at this graph. We want to determine the domain, so the whole x values. Remember, that's left to right. So the furthest left this graph goes is at a -11, and then it goes on forever. So we have bracket -11 to positive infinity. Then we want the range. Remember, that's the low to the high. So this looks like the low point. That looks like the high point. That looks like from -4, 2, 4, 6, 8 to 10. So we have bracket -4 to 10 bracket. On number 3, we're going to determine f of -8. Recall that means when x is -8, what is y? So we go out here to -8, come down here, and y is -4. So f of -8 equals -4. And then on number 4, we're asked when y equals to 10, what does x equal? Remember, we've done this in a previous video. So when x is equal to 10, which happens to be up here, what is x? And that is positive 2. So those are some review questions. Now let's look at the new stuff. It says find the intervals where the function is increasing. I want you to pretend that you started out here, like you're on a roller coaster and you're about to take off. I want you to walk along, right along this graph, and tell me where you're going uphill, increasing, and then mark that. I'm going to do that in purple. So I get here and I'm climbing uphill, and then I go down. And then I go up, then I go down, just like those fun-filled roller coasters, and then I go up, and then I flatten out. So where in the domain, I want the x values where this is happening. So it looks like from here to here, from here to here, and I'm going to call that 5, close enough to here. So how do I write that? So they need to be open intervals. So meaning use parentheses. So we have from -8 to -2, and then from 0 to positive 2, and it looks like from 5 to 9. Again, from here to here, from -8 to -2, from here to here, from 0 to 2, and from here, and that looks about 5 to 9. Now, what about decreasing? Where are we going downhill? Well, almost everywhere that we're not going uphill. So we're going downhill here, down here, down here, but again, this part we're staying flat. So part of the domain. So from -11 to -8, and then from -2 to 0, and then from positive 2 to 5. And then the last question says, where is it constant? That means flat. Well, go back to the domain from -11 to infinity, and that pretty much covers everything that we've listed as far as increasing and decreasing, except for the part from 9 on, because from 9 on, it's flat, which means it's constant. So again, I'm going to be consistent with those open intervals. That's not quite consistent throughout most textbooks, but let's just say open intervals, always use parentheses and you'll be fine. Now find the numbers meaning the x values at which f has a relative maxima. Now remember, the maxima is when you're going up and then you came down and you hit a peak. Well, we hit a peak here and here, and that is not a peak. So remember, it goes from increasing to decreasing. So what are those x values? At -2 and +2. So -2 and +2. Then it says find the relative maxima. That again differs by what books mean what, but here we want the points, the ordered pairs where this occurred. So we know the x value is -2, what is the y value? The x value is +2, what is the y value? So at -2, we're here at 2, 4, 6. So at -2, we're at +6. And at +2, we're at +10. Now I know the next question is going to probably be something about minima, so while this is on my screen, so again, that would be a relative minimum, that would be a minimum, that would be a minimum. So let's just, so this happens at -8, when x is -8, y is -4. This is at 0, 0, and this is at 5, 0. So we have 3 relative minima. So the numbers would be at -8, at 0, and 5. Remember, these are just the x values. This means the points. Again, some books mean just the y values, but let's just stick with the points to make it easier. So we have that point, that point, and that point, and those are your minima. Number 12 asks us to go back and review what are all the intercepts, meaning where does it cross the x-axis, where does it cross the y-axis. So let's see. So we cross the x-axis here at -10, 0. We cross the x-axis here, that looks about -5, 0. We cross there 0, 0, and there at 5, 0. So those are the x-intercepts. Now what about the y? Well, the only time it crosses the y-axis is here at 0, 0. So we have -10, 0, 0, 0, 5, 0, and -5, 0. And again, this one is an x and a y intercept. Number 13 is different. Find the values of x for which f of x, which is y, is less than 0. Again, that's a really interesting way to write that. Find the values of x, again that's the domain, for where y is less than 0. What does less than 0 mean? It means negative. So where are y values negative? They are below the x-axis. So this is the x-axis. What part of that graph is below there? All of that. Sorry for all my squiggles. So what are the x values in there? Well, it goes from -10 to -5. From -10 to -5. That's the domain, or the x values, where y is negative. Now number 14 is really a trick question. Find the zeros. You're going to see that word a lot. That still means the x-intercepts. Where does this graph cross the x-axis? Well, believe it or not, that's all of those. So we would just repeat that, and I think you can see why they're called zeros. Look at this. 0, 0, 0, 0. That's what that means. Zeros are x-intercepts. Alright, so we're going to determine the domain from left to right. This doesn't have any arrows. It's kind of a little bit simpler graph. So we go from left to right, and we're looking at the x values. So we go from -3 to +3. Range, the low to the high, and we want to look at those y values, and we're going to go from -2 to 2. Increasing, again, pretend that you start on the left-hand side and see where do you walk uphill. I'm walking uphill, stay flat, walk uphill. And you want those x values of where that's happening. So from -3 to -2, we're just going to be an open interval, so use parentheses, and then from 0 to 2. Decreasing, where did you walk downhill? Well, from there to there. And again, x values. So from 2 to 3. And then constant, again, that means where is it flat? Just right there. What are those x values? And again, if you put all three of those together, that should be the domain except for where you change parts, where from the parentheses to the bracket. But if you put all these numbers in order, it should go from -3 to +3. All right, so number 6, find the numbers, and again, those are the x values where f has a maximum. So where did we hit a high point? Not here, but here. So I'm going to erase some of this so I can see this actually. So this would be not only a relative maximum, but the maximum. That's the only high point in the graph. So that number is 2, and then staying consistent, we're going to write an ordered pair here. And then number 8, find all the intercepts. So where does it cross the x-axis? Where does it cross the y-axis? And this is nice because these are all labeled for you. That's a dot, -2.30. We have 0, 1, and we have 3, 0. Okay. Number 9, a little bit different from the last one. It says find the values of x for which f of x is greater than 0. So where is y positive and equal to 0? So that is above the x-axis. Okay, so here's the x-axis. What part of this graph is above? Well, all of this part, right? And where does that go? What are the x values? From -2.3 to 3. And we're going to include them because at those points y equals to 0. So from -2.3 all the way to 3, bracket again because of that equal sign. So number 10, find the zeros. What does that mean? It means the x-intercepts. So if I come back to number 8, the x-intercepts. So that's -2.3, 0 and 3, 0. So again, we're looking at where the domain is increasing, decreasing, or constant. So that the domain are your x values, but you're looking at what y is doing. And that is sometimes very confusing for students, but keep with that domain.